scientists and science lovers. Today, we embark on an exciting journey through cosmological theories, exploring how scientists attempt to decipher the structure and boundaries of our universe, from the Big Bang Theory to concepts of an expanding universe and even the hypothesis of a multiverse. Are you ready for this thrilling cosmic adventure? Buckle up, let's begin. Let's start our exploration with one of the most significant theories in cosmology, the Big Bang Theory. The Big Bang Theory is a way to explain how the universe began. It's not an explosion in the usual sense, but rather a moment when the universe started expanding from a very hot and dense state. Here's a simple explanation. 1. The beginning of everything. Imagine that all the material in the universe, all the stars, galaxies, planets, and even light was compressed into an incredibly tiny point. This point was so hot and dense that it's beyond anything we can currently imagine. 2. Expansion. About 13.8 billion years ago, this point suddenly started expanding. This expansion wasn't an explosion, but rather a rapid increase in size. This was the birth moment of the universe as we know it. 3. Cooling down. As the universe expanded, it began to cool down. From this initial hot plasma, the simplest elements, like hydrogen and helium, started to form. 4. Formation of galaxies and stars. Over time, these elements began to come together under the force of gravity, forming stars and galaxies. The Big Bang Theory is supported by a multitude of observations, including the expansion of the universe, confirmed by the redshift of light from distant galaxies, and the cosmic microwave background radiation, which is kind of like an echo from the beginning of the universe. Thus, the Big Bang Theory doesn't describe an explosion in the traditional sense, but rather the process of the birth and evolution of our universe from an initially hot and dense state. But what triggered the Big Bang? This remains one of the greatest mysteries. We will also look at how the discovery of cosmic microwave background radiation by Arnaud Penzias and Robert Wilson became a key piece of evidence supporting this theory. One of the key discoveries in astronomy, which played a huge role in our understanding of the universe, is Hubble's law. This law was proposed by astronomer Edwin Hubble in 1929. Simply put, Hubble's law states that the universe is expanding. This means that galaxies are moving away from each other. The farther away they are, the faster this happens. You can imagine this like an inflating balloon. If you think of the dots on a balloon as galaxies, as the balloon inflates, the dots will move away from each other. And the farther the dots are from each other initially, the more it will seem like they are moving away as the balloon expands. This discovery was significant because, before this, many scientists believed that the universe was static, meaning it did not change over time. Hubble's law showed that this was not the case, and that the universe is constantly evolving. This discovery also raised questions about the ultimate fate of the universe. Will it expand forever, or will it eventually start to contract? Hubble's law was one of the first steps towards the Big Bang Theory, which is now the main theory about the origin and evolution of the universe. To measure the speed at which galaxies are moving away, Hubble used a phenomenon called redshift. Redshift is a phenomenon in astronomy where light from distant stars and galaxies shifts towards the red end of the light spectrum. It's a bit like the sound of an ambulance siren changing as the vehicle moves away from you. When a galaxy moves away from us, the light it emits stretches out, and its waves become longer. Longer light waves fall into the red part of the spectrum, hence the name redshift. This is one of the key pieces of evidence that the universe is expanding. Furthermore, we will discuss how the cosmic microwave background radiation, accidentally discovered, provides a unique view of the early stages of the universe, and how it assists astronomers in their research. The cosmic microwave background radiation is a kind of afterglow from the Big Bang, the event that created our universe. This radiation can be detected almost everywhere in the universe and represents a faint signal that is evenly distributed across space. Imagine the cosmic microwave background radiation as a thermal trail from the beginning of the universe. This radiation gives scientists important information about what the universe looked like just after its birth and how it has evolved since then. The discovery and study of cosmic microwave background radiation have become one of the most important moments in space research, helping us understand how the universe's story began. Dark matter is not just empty space or invisible material. It exists in a form that is different from ordinary matter, which makes up stars, planets, and us. Its invisibility and unusual behavior make dark matter one of the biggest mysteries of modern science. Our observations of the expansion of the universe have also led us to the discovery of dark matter and dark energy, two elusive components that make up the majority of the universe. Dark matter is a very mysterious entity in the universe, and scientists are still trying to figure out a lot about it. Its name dark comes from the fact that it does not emit or reflect light, so we cannot see it directly with telescopes. Nonetheless, scientists know that dark matter exists due to its gravitational effect on visible objects and phenomena in space. For example, it influences the movement of stars and galaxies and how light from distant objects bends when it passes by large clusters of dark matter. So, what is its mystery? The thing is, although dark matter makes up a large portion of the mass in the universe, we still do not know what it is actually made of. There are many hypotheses and theories, but none have been confirmed 100% yet. Finally, we will explore one of the most exciting and controversial theories, the multiverse hypothesis. The multiverse hypothesis is the idea that our universe is not the only one. According to this hypothesis, there are many other universes, each with its own laws of physics, its own galaxies, and possibly even its own forms of life. Simply put, it's as if our universe were one book in a vast library where each book represents a separate universe. Some of these universes may be very similar to ours, while others could be completely different and follow entirely different laws of physics. The theory of the multiverse emerged not from a single source, but rather as a result of developments in several areas of theoretical physics and cosmology. Here are some key factors that contributed to the emergence of this idea. 1. Quantum mechanics. In the world of quantum physics, there is the concept of multiple possible states of a particle. The famous experiment known as Schrödinger's cat illustrates the idea that a particle, or the cat in this experiment, can exist in several states simultaneously until observed. This led some theorists to the hypothesis that there could be many parallel universes where all these possible states are realized. 2. String theory. In string theory, especially in its development in the form of M-theory, the possibility of different universes existing in higher dimensions arises. According to this theory, our universe could be one of many universes floating in higher dimensions. 3. Cosmic inflationary period. The idea of cosmic inflation suggests that the early universe experienced a period of exponential expansion. Some inflation theories propose that such inflationary events could occur in different parts of space, creating multiple bubbles or individual universes. 4. Observations of cosmic microwave background radiation. While these observations are not direct evidence of a multiverse, they have contributed to the development of theories about the structure of the universe, which may imply the existence of other universes. However, it should be noted that, at present, we have no direct evidence of the existence of other universes, and this concept remains largely in the realm of theoretical research. The theory of the multiverse also generates a range of philosophical reflections and questions that make us reconsider reality, our existence, and humanity's place in the universe. Here are some of the key philosophical themes related to this theory. 1. The concept of reality. If a multiverse exists, it forces us to rethink what we consider to be reality. The question arises whether parallel realities exist and how they are interconnected with our own universe. 2. Questions of free will and determinism. In the context of the multiverse, the question arises whether all possible choices and events are predetermined in different universes. This touches on debates about free will and fate. 3. Ethical and moral considerations. The existence of multiple universes where different scenarios of history can unfold may impact our understanding of morality and ethics. For example, how should we act here and now if, in another universe, our actions have different consequences? 4. Questions of significance and uniqueness. The idea of a multiverse can raise questions about the significance of individual existence. If there are an infinite number of possible universes, how unique are any events or lives in our own universe? 5. Reflections on infinity and eternity. The concept of the multiverse leads to thoughts about infinity and eternity, about limitless possibilities, and how this affects our understanding of time and space. 6. The search for meaning. In a world where an infinite number of universes exist, each with its own laws and histories, the question arises about the search for meaning and purpose in existence. These philosophical reflections show how deeply and broadly the theory of the multiverse touches on fundamental questions about our understanding of the world and our place in it. Thus, the multiverse hypothesis represents an exciting but controversial idea that expands our conceptions of the cosmos and our place in it. We are just beginning to understand the scale and complexity of the universe. Each new theory and discovery opens new horizons and poses new questions. What lies ahead in our journey? What mysteries of the universe will we uncover in the future? Join the discussion in the comments and share your thoughts. Don't forget to subscribe to the channel to learn about new discoveries in the world of astronomy and cosmology. Many amazing discoveries await us. See you soon in the cosmic expanse.